Welcome to page 2. For page 2, we're starting to work with proofs a bit. And of course, I think we all know that we make note of our givens first. And here they have two different things. We have L is parallel to M, and angle 2 is congruent to angle 4. So now if we go to our picture, we should mark this fact. L, let's embed that in here a little better, is parallel to M. There we go, erasing. And we also have angle 2 up here is congruent to angle 4 down below here. So we may use that later on. So what are we trying to get to? Notice your proof statement. We're trying to prove that these other two lines here and here are parallel to each other. Notice we've already got angle 4 and angle 2 marked, so I know they're equal. So since we know the red lines are parallel, here and here, we can use properties of those lines. Now the first thing they tell us is angle 1 is equal to angle 2, as I'm looking at step 2 here, right here. And let's look at our figure and see why that might be the case. As I look back to my picture, angle 1 is related to angle 2 by corresponding angles, and this is with the red parallel set. So this is the corresponding angles postulate. They also tell me, looking at step 3 now, that angle 2 is equal to angle 4, and if I look back to the top, that's a given. So in hindsight, I guess we wouldn't really even have to write that up there because it does show up later. Okay, we're at a place where we want to try to make a connection. 1 is equal to 2, and 2 is equal to 4. That implies that if angle 2 is equal to itself, just in your statements here, it seems to follow that angle 1 must also equal angle 4. And the reason that is these two ideas from steps 2 and 3 are pulled together, and this is a classic example of the transitive property of congruence. And once we've got these ideas together, we can use the fact now that 1 is equal to 4 here on the picture and here. Notice now those two angles I've shaded in blue are basically corresponding angles for the NP setup, with L being your transversal, that one I marked in red there. So if those angles are equal, angle 1 equals angle 4, that's enough for us to say now in conclusion, N is parallel to P because of the corresponding angles postulate converse. Again, we didn't start with angles parallel, but we used this to prove angles parallel, similar to what we said on the first page. Try to let that sink in a little bit for you. And we'll move on to number 8 shortly. Readjust my screen here. Okay, here we go. Looking at number 8, checking out the givens. Looks like they are both marked on the figure already. So I see one of my given statements is here. This is the easy part again. And if I look down a little further, I locate another given that they happen to mention here. So we'll fill those in right away. Now they tell me angle 1 is equal to angle 2. Why in the world could that be? If you notice on the picture, those two are pictured in corresponding angle position, which is probably why they mentioned it just after they said K and L are parallel to each other. So these are equal, and the reason is the corresponding angle postulate, O postulate. They also tell us that K is parallel to M, and it looks like down below that 1 and, let me change color so that's obvious. It looks like 1 and 3, the only ones they're actually focusing our attention on, must be equal to each other for the same reason. Corresponding angle postulate, and then we'll just write angle 1 is congruent to angle 3. Okay, so let's see what we got here. Looking at what I have, they hint to us that the transitive property is the reason we can say the next statement. And if we look at what we've written, I see that I've written angle 1 in two different spots equal to two different angles. And as we talked about what transitive means, transitive is the training together, the linking, the hooking together of two ideas. So if angle 1 and equal 2 are the same size, and angle 1 and angle 3 are the same size, it stands to reason in logic, and this is the name of that reason, that angle 2 must also be equal to angle 3, kind of because the angle 1 is your connecting link, like a train car, train, transitive. So let's take a minute here and see where we're at. I just wrote that angle 2 is equal to angle 3, and notice between these particular lines, L and M, those two angles now, one in red, one in blue, are in corresponding angle position. And what I'm trying to show is true, look back up at your proof statement, that L and M, those same two lines that we just noticed, 2 and 3 are equal to, we want to prove those same two lines parallel. Notice 2 and 3 are again in corresponding angle position. So I guess the reason we might say this is true is the CA postulate. And what we're saying is, remember our proof statement always goes here, guys, right, anyway? So by default, that will become last. And now, the reason again is because of what we've been talking about over this last several pages. We've shown that angles are equal to help us prove parallel lines. That is, of course, the converse of the correct angle matching name. So I've got to put my word converse here at the end. Nice and neat like that so Mr. Grams can read it, right? Okay, continuing on for number 9. Are we having fun yet? Gosh, I hope so. For number 9. Again, the givens, basically they just list the image, right? So basically check the picture, and we've got some labels on the picture that tell us what is what. So it looks like we have angles in parallel position. We're supposed to prove x is equal to 74. So if these lines are parallel, I see corresponding angles there. And those angles, x plus 66 degrees, we know should be equal to each other, 2x minus 8. So because I know something about corresponding angles, we can say so. And the rest of this now is going to be algebra based. First step that we do, I'll change color for the steps. So to show those steps, we're going to be subtracting x from both sides. And there's a hint in exactly what I said there. This is the subtraction property of equality was our abbreviation. And when I subtract, I end up getting 66 equal to x minus 8, carrying that out. And then the last thing, of course, to move, if you want to write it small underneath, you may. And that's a hint as to the reason. What have we done to both sides? Well, we've added something to both sides, and that is the addition property of equality. That says that if you add the same thing to both sides of an equation, you will end up getting a new but equal equation to the first. And here we end up with our 74. Now maybe we want to throw in the extra step here, which maybe isn't too bad of an idea. Notice this doesn't match the exact proof statement yet, does it? Our proof statement is so similar, but they've actually come up with a specific math reason for this. And that reason was called, if you remember, the symmetric property of equality. Try to make my R a little better there. Symmetric, that's an E. Lovely. And there you go. End of page 2.